Hello everyone and welcome back to my channel. Today we're going to be learning about polygons. Okay, so before we go around and start learning about polygons, we need to learn specifically definition of a polygon. So let's get started. So the polygon definition is polygon definition. So the definition of a polygon is an n-sided figure. So it's basically any shape with sides. For example, a square, rectangle, triangle. Um, it can be a pentagon. It can be a pentagon. Sorry if my pentagon is not very good. A hexagon. But let's think about this. Can a circle be a polygon? Can a circle be a polygon? Well, if we look back to our definition, the definition of a polygon is an n-sided figure. So if you look in a circle is just a round shape. There are no sides in it. This means that a circle is not classified as a polygon. Okay, so that is the definition of a polygon. Okay, now let's talk about two types of polygons. There are two types of polygons. There is a concave polygon, concave, and then there is a convex, convex. So we'll talk about concave first. So a concave polygon is basically any part of the diagonal that exists outside the figure is concave. For example, so basically if any diagonal of the polygon exists outside of the figure, then it is concave. So we'll take an example like this. So a diagonal is any line that connects 2 points of a figure. So as you can see here in this figure, if we connect these 2 points using a diagonal, the diagonal lies outside of the polygon. So the inside would be like right here, and this lies on the outside. So this is what we call a concave polygon. Now if we go on to a convex polygon is that no diagonal of the polygon occurs outside of the figure. So for example, if we just take a trapezoid, we take a trapezoid right here, we can see that none of the diagonals exists outside of the polygon. So an important thing to remember about convex polygons is that all regular polygons are convex. Since this is not classified as any real shape, we call that a convex. Any shape that you can think of, a square, triangle, rectangle, trapezoid, not circle because circle is not a polygon, obviously. So any shape you can think of is a convex polygon. So that's an important thing to remember. Okay, so now let's go ahead and write down the definitions of a polygon. So definitions of a concave polygon is any, if any, if any part of the polygon's diagonal lies outside of the figure, then it is concave. Okay, now the definition of a convex polygon would be no diagonals of the polygon lie outside of it. So as you can see previously, we drew some examples. So those are the examples of concave and convex polygons. Now feel free to pause the video and take notes of this. Now we're going to move on to some theorems that are associated with polygons. So the first theorem is called polygon sum theorem. Okay, so let's go ahead and talk about the polygon sum theorem. So the polygon sum theorem is basically how to find the total number of angles measures in a polygon. So let's start off with a triangle. So a three-sided figure. So what this theorem mainly depends on is finding out how. So the most basic shape is a triangle. So it's just basically counting how many triangles there are in each polygon. So the angle measures of a triangle, if you don't know, add up to 180. So if this is angle 1, so let me just draw it bigger. Uh, so if we have a triangle right here, and this is angle 1, this is angle 2, and this is angle 3. Angle 1 plus angle 2 plus angle 3 equals 180 degrees. So that's how the triangle sum theorem works. So this theorem is based off of that. So if we have, for example, a three-sided figure, well, how many triangles does that contain? Well, it contains one triangle. So that means the total angle measures of that polygon would be 180 degrees. So obviously a three-sided polygon is a triangle, so that one was easy. Now let's move on to a four-sided polygon. So it could be the rectangle, trapezoid, it could be a square, anything. So any four-sided polygon. So how many triangles can we find in this? Well, we can find two triangles. So since there are two triangles, we just double this, and we get 360 degrees. So all the angle measures in a four-sided polygon equal 360 degrees. Same like 5. So five-sided polygon, such as a pentagon. How many triangles does that contain? Well, that contains 3 triangles. So if we do 180 times 3, we get 540. So that's how many degrees are in a five-sided polygon. So this polygon sum theorem is basically, so if we have an n-sided polygon, we would calculate the angle measures, total angle measures, by doing n minus 2 times 180. The reason we do n minus 2 is because if we just had 3, we cannot have a one or a two-sided figure. Because if we had a one-sided figure, that would just be a line. And if we had a two-sided figure, we can't really connect them. If we try to connect them, we would just have to go over the same line, which is not possible. So that's why we do n minus 2 times 180. The n is basically the number of sides, and the 2 is taking out the two possibilities that are not possible. So that is the formula for the polygon sum theorem. Okay, now we'll move on to the last theorem that is associated with polygons. This theorem is called the polygon exterior angle theorem. So let me write it down. Polygon exterior angle theorem. So I'm just going to write THM for short, theorem. Okay. So say we have, we'll just draw a triangle, for example. This is just to demonstrate the theorem. So say we have a triangle right here. Let me make it a different color. So say we have a triangle right here. And this will just, this line just extends, because a line is just any, it's just any 2 points that continue on forever. That's a line. So we'll just label this as A, B, and C. Those are the 2 points. And we'll name this angle as X. And this is Y, and this will be called Z. So those are our points, and those are our three angles. So what this basically states is that exterior angles of any polygon will equal 360 degrees. So what that basically means is that if we were to continue this line, like from here, if we were to continue it, and if we were to continue this, what this is basically saying is, so let me write the A somewhere else so that we can, okay. So what that basically is saying is that this angle, uh, this angle plus this angle plus this angle will equal 360 degrees. That's basically what this theorem says. Whether it be a square, so if we were to do a square, so a square would be easier to show. Since all angles in a square are 90 degrees, if we were to extend these lines outwards slowly, we would see we can see that the exterior angle of this square is 90. This would be 90. This would be 90. And this would be 90. So there's the exterior angles of the squares. And since those exterior angles, so since we know that a straight angle is just a line, so this would be 180 degrees, we can just do 180 minus 90 to get 90 degrees. So these are all 90 degrees. So if we do 90 times 4, we get 360. So um, that just proves our theorem to be true. So 360. So that works for any polygon, even if it was like a 10-sided polygon, like a decagon or an octagon, a hexagon. Any polygon you take, it works for that. So always the exterior angles of any polygon will equal to 360 degrees. Now, an important thing to remember with both of these theorems that I just taught you, both of these theorems only work with convex polygons, because convex polygons are basically all regular polygons. The diagonals have to be lying inside of the figure. Then only these theorems work. So that would be it for today's video. Thank you so much for watching, and if you have any recommendations or ideas that you would like me to post, I would love to help. Thank you.